Hi everyone, how are you?
Doing good.
Good.
I would like to introduce our expert, Ivan Krylov. Ivan is a JVM developer. He is developer for the last 15 years. I guess many people who see this talk not have a lot experience like Ivan. And Ivan have specialized in GIT compiler infrastructure and IoT compilation. Ivan, could you please introduce our speaker?
Thank you, Andrei. Yes, I am Ivan Krylov, and people may remember me from previous seasons of the conference. But it is my greatest pleasure to introduce to you Shelley Lambert from Red Hat. And so Shelley has been serving on a technical steering committee at Adopt OpenJDK for many years. Do you remember how many years, Shelley?
Well, it's almost as long as the steering committee has existed.
Okay.
So 3.5, 4 years.
Okay. I should have welcomed you first. Good morning to you. Good evening to the audience. Good morning to you. And how long is it that you've been working with the Java virtual machine code base?
Yeah. Well, I joined the Java ecosystem 16 years ago when I, after many years as a network management software developer, I joined the Java program at IBM to add support for IPv6. So if you remember when IPv6 was added to the Java language, that's when I was added to the Java ecosystem.
Yeah, that is a very long span of a project. I don't know how many people in the audience have experience of working on a project of that length. And during this talk, I'm going to run a poll to ask people of how long are the projects they are running on. Are these like 1 year project, 3 year projects, maybe 10-year projects? We'll find out how relevant these long projects are in their career. Without further ado, Shelley, I would like to head it over to you, and let's start it.
Yeah, fantastic. Well, thanks so much, Ivan. And yes, I am very interested to know how long-lived your projects are, what you're working on, and what kind of time frame you're working towards, because that is a factor in determining how much you need to pay attention to whether you dismantle technical debt or not. So I'm going to just dive right in. My name is Shelley Lambert. You've gotten a bit of an introduction, and I'd like to kind of talk about a few things. First of all, what is technical debt and hubris? And I'll get to that in a moment. We'll cover how I actually handle the challenges of a long-lived project and how to deal with accumulating or growing technical debt across many years at a project. And then talk about how you measure how well you're doing. So those are the overarching goals today, and I'll get right to the definitions. In my opinion, or one of the definitions of technical debt is this cost of additional future work caused by either a decision to implement something in an easy way or in a limited way, or it wasn't a conscious decision, it was by accident or by lack of skills or some other reason, an unintended reason that something was implemented in a limited way. So in either case, there's this useful quadrant that helps you think about technical debt that Martin Fowler put together. And there's either we intend to do something quickly to get it out quickly, and we know we're going to have to come back to it, so that's intentional. or we didn't intend to, we just maybe didn't understand the problem we were trying to solve. So we solved it in a suboptimal way. And then there's what you do in terms of your behavior once you have technical debt. The reckless side of the quadrant is you say, I don't care, and you're not going to deal with it at all. And then the prudent side, prudent or cautious side, is I am aware that we have technical debt, and I'm going to try to attend to it throughout the course of this project so it doesn't get worse. So the notion here then is you want to be in that intendant prudent portion of the quadrant. And I will say that technical debt doesn't have to be a bad thing. It can be this conscious choice that you say, we got to get this product out to market quickly. So we're going to do the first part of a solution or an easy approach at first and come back to it later. And usually there is an additional cost. There's the tax or the interest that accumulates when you have to come back to something later. So teams and projects have to be aware of that. The next definition that you'll need, because this talk is called Dismantling or Taking Apart Technical Debt and Hubris. Hubris is, the definition of that is excessive confidence or arrogance. So another poll we could put out to the audience would be, have you ever encountered or worked with anyone that was full of hubris? Maybe they were excessively confident or arrogant. The other part of this story is that hubris tends to lead to a lack of questioning and planning, short-sightedness, and harmful behavior in a project. So if an entire team was overly confident, filled with hubris, not listening to all the ideas in the room, not making plans for being humble and trying to fix problems, then you've got yourself a scenario where you could have a project that's going to suffer because, one, you'll likely accumulate more technical debt, which means more work, and you'll be digging yourself into a hole. So we've got these definitions, and we'll see how would we go about dismantling some of these things that could make your project or your team not function so well. And I'll add one more piece of complicated piece to the story, which is any team working on anything gets requirements brought to them, whether it's from a business team that's gathering them from customers, whether it's from driven from an open source community that is requesting stuff. It doesn't really matter in this case who the stakeholders are, but there's a lot of inputs and requests coming in. And I will say, when they come in en masse, all at once, it registers as noise. And some of this noise can even be conflicting. So someone wants something, wants to be able to run more tests, but someone else wants to run less tests and go faster. And those can conflict against each other. What are you going to do in this scenario? And this scenario, by the way, of requests coming in and requirements coming in, if you don't handle these requests well, can also lead to causing more technical debt. So as we had said on that definition, technical debt being potentially being introduced because you didn't understand a requirement well and you built something to solve a problem that didn't need to be solved or wasn't the actual request. So handling and categorizing this noise is going to be important. So I think the other thing before I dive into how do we deal with that noise is giving you context of the project that I'm currently working at. These are now slightly older stats, but the notion here is that at Adopt OpenJDK, if you haven't heard of us, we build binaries out of the OpenJDK source project and distribute them for a lot of different platforms, a lot of different implementations. And to date, we have over 250 million downloads. So this was over the course of the past 4 years, we've gone from 0 to 250 million. We have a rapidly growing install base. We run 100 million tests per release. So it's a massive scale DevOps project. And we have to be growing and transforming while keeping up and maintaining the pace of Java releases, which, if you note, the cadence of those releases has increased over the past few years. So it's a little bit like changing the tires on a car as it's driving down a freeway. And just a few things about the numbers then. These numbers were based back in March of 2020. By November of 2020, our Adopt OpenJDK numbers had doubled, and by November of 2020, the JDK 11 numbers were even larger. So to give that note. Now, go ahead.
Hi, Shelley. This is Ivan. I just wanted to draw attention of the audience that first of all, we do have a Telegram channel that is live, and that's where we collect questions during this talk, and we may answer some of them during the talk, some we'll take after the talk. But anyway, find the link to the Telegram channel on the conference webpage, and be sure to join this channel. Secondly, in that channel, I just posted a poll where we are interested to find out how long are the projects that you are working on. So some of you may be working on very short-lived projects that from start to death, essentially, it's like less than a year. Some of you are working on like 3 or 5 or 10-year-long projects. We're talking about Adopt OpenJDK through the course of this talk, so that's a much longer than 10 years project. But we would like to know where you are, and we can discuss this poll results perhaps later on. But please join the Telegram channel. Please answer to that poll, give your answers, and be sure to ask questions on that channel. Back to you, Shelley. Thank you.
Yeah, and it's a timely, thank you for asking for people to finish that poll, because it is really interesting, the perspective of how long you need to care for the product you're building, how long-lived it is. Because if it is from start to death, a 1-year piece of work, there isn't a whole lot of time for technical debt to accumulate. You have less concern about handling incoming requests, less concern about dismantling the debt, because you haven't really perhaps had a chance to accumulate much of it. But I'm about to talk about Java and the legacy of a now coming to be 26-year-old language. So that's a long time to be running a program, and that's a long time for things to accumulate. And a lot of different people interacting, and a lot of different activities that potentially, not all of them have been organized and coordinated together. So you can start to see the burden of that in longer-lived projects. So I've broken out how to make sense of the noise here in terms of 4 different modes. From the perspective of a long-lived project, we have to think about a maintenance mode. So we have a lot of legacy. In my case, I'm going to talk to you about the tests and testing of the Java language. And there's a lot of legacy tests over the course of that time. And you'll also note that Java has this notion of backward compatibility. So each new version of Java should still be able to run programs that were written 20 years ago, 25 years ago. So a lot of the tests that were written back then are still valid, but do we keep them? Do we try to modernize them? They were written in older frameworks or before frameworks even existed. So there is the notion of what do we do to care for these tests or to manage them and maintain them. And in some cases in this mode, we would actually get rid of them, cull them. In other cases, we would work to modernize them. And in terms of the millions of lines of test code that there are, it might not be feasible to overhaul the whole bunch. So we still have to work in this mode. In terms of the next mode of how we work, what types of activities we do, we will think about it as development transformation. So how do we change and improve the world that we live in and how we work? And in terms of Java, this includes, as Java, the language, grows up and continues to add new features, how do we support those new features? So in this mode, we're thinking about improving how we work and also keeping up with new features. And that keeping up with the release cadence of Java. Every few months, we're releasing something. And in terms of the next mode, and this is the really fun mode to be working in at a project, would be innovation mode. And these are, what are the new ways we can think about doing what we do? New ways of testing, new ways of running a massive scale DevOps project. So these might be looking at deep learning or machine learning. This might be defect injection or combinatorial test design. Ways that we prototype and change how we work to see if it improves the world for us or makes it worse, and making decisions in that space. So collaborating with research here as well. And then finally, the fourth mode. So as all those requirements come in and we're trying to categorize those requirements and see where they fit in how we work, the fourth mode that I think about and is certainly valid for our open source project, but I believe is also valid for projects that aren't open source. And this is the open and transparent open source readiness mode. And in this way, for us, it's important because we are an open source project. But even if you weren't, thinking about how you minimize the proprietary tools that you are working with, how you move towards using open tools, how you make what you're working on more portable and modular and flexible. So, and I guess the point for us for this as well is because we went from being an internal project where we were only running and testing things internally to then open sourcing millions of lines of test code, those now are in the spotlight. The world can see them. Anyone can go look at them. There was a work in the maintenance mode to make sure that the test material was ready to be have a light shined upon it, and making sure that we treat the quality assurance program in the same way we treat product code, that we have code reviews, that it follows a certain set of guidelines, and that we are thinking of it as a first-class citizen. All right, so how do we look at that? We're deep diving into those legacy tests of Java. I promise I won't spend too long here. I know this probably isn't everybody's world, but it is certainly my world. Looking at all of these tests that anyone has ever written in the history of a 26-year-old language, no one used the same framework. It seems everyone wanted to write their own frameworks. Some of this is because things were written over the course of time and new, better frameworks came into existence. In some cases, this was an act of hubris where someone would say, I can do better, I'll write my own. In some cases, it was because there were, things predated frameworks completely. So my world right now looks like this, or looked like this as I started trying to make sense of these legacy tests. We categorized the tests into different groups based on where we were pulling this test material from. And we saw that each of these groups were using 1, 2, 3, 4, 5 different frameworks underneath: TestNG, JTReg, SDF, JUnit, SVT. For performance benchmarks, it's all over the map. For compliance tests, it's Java Test Suite. So all of these different frameworks, and that meant we had to learn all of these different command line options on command lines to be able to run them. And that wasn't going to fly because that is a nightmare of work. So I've already listed some of the problems here, why this is a problem, but even if you had to bring in new people to a project, oh, could you learn these 20 different frameworks, please? That seemed unreasonable. And documentation and guidance and trying to teach people was going to be wholeheartedly impossible. So we dealt with this in our transformation mode as a way of saying, okay, we'll lay down this thin layer called test kit gen. Doesn't really matter what it's called, but it's a veneer that says we're going to make all these frameworks look and feel the same to automation and to a development team that might want to use it locally. So instead of those previously many different command line options that we would use, if I wanted to run something from this group, I could just go make functional and it would run those, and all the way across the board, so that each one of these types of tests, including performance benchmarks, would behave the same and be predictable to both new people coming on board and to automation tooling. And on the note of automation, how we thought about it, think in terms of this massive scale DevOps and trying to bring in testing, a common standard way of testing this large language, complex language. I already mentioned that test kit gen, the lowest layer. We have that as our first layer, and I can go make functional on my command line, and it's going to be able to run stuff. It also has a bunch of other features in it that let me run things in parallel, let me execute or exclude tests in a common way, and it also reports tests in a common way. So not all of those old test frameworks have test reports that behave the same either. So one thing Test Kit Gen does for us is enforce a common, very simple standard way of reporting test results. And again, useful for upper layer automation. So as we move up this layer cake, in the middle, we have our CI systems. And to begin with, the project selected Jenkins, but we support other systems. The notion here is this middle layer should have very little functionality or features because we want to be able to swap this layer out. This layer could change on us. People prefer one or the other, Azure DevOps, or they want to run stuff in GitHub Actions or in Jenkins. So choosing not to put a whole lot of features in this layer was important for us so that our maintenance story is less. And then finally, this icing on the cake, this test results summary service, which allows us to query things across multiple different CI systems and allows us to add some extra functionality, searching, sorting, filtering, plugging in some deep learning services, and having a graphical or a visualization of all of the 100 million tests that we run per release. Okay, that's a lot of detail that you may or may not care about, but I wanted to introduce it because I'll be talking about some of these layers as examples. So that maintenance mode, each one of these modes, the 4 activities we were talking about, maintenance mode being the demotivating mode that no one really wants to do a whole lot of work in, but we have to in a long-lived project. This quote really captures what it feels like to be here. I put a quote for each of the modes. Stuff was always broken. The code was broken. The tests were broken. And the team was broken. I knew what it meant to be buried under quality and technical debt, where every innovative idea was squashed, lest it risk breaking the fragile product it depended on. So this is what happens if technical debt accumulates so much that you no longer are able to move. You end up being squashed under it, and you can't even think about innovating and doing things in a new way because you're buried at this point. Why we want to be dismantling technical debt along the way is to avoid being squashed under it. And though no one likes to work in this mode, taking a little bites off this sandwich each iteration is a good idea. We try to minimize our effort here, but we always remember that it's important to do some work here. Because if all we're doing is saying there's a bunch of failures and now things are failing or we've excluded things, if we just continue to not deal with problems and kind of sweep them under the rug, we're going to be hiding real problems. And the estimate would be that, a defect in the test material, if that's failing, but it's not really a product problem, and you're just letting it fail so the test doesn't run, you're going to be hiding a product problem 1 out of 10 times. So that's not a good scenario. For development transformation mode, the quote here is, "The secret of change is to focus all of your energy not on fighting the old, but on building the new." And I like this mental headspace a lot, because that means instead of always firefighting when you're back in maintenance mode, putting out fires, dealing with crisis, we always take time to work on building something new, thinking about how do we improve our world, how do we improve the way we work. And in this mode, it's really about improving workflow. So looking at what causes a team friction and removing it. If something you have to change 5 files, to make some change happen, could you refactor things so that you could only have to change one place? Or if it takes a manual effort, could something be automated to make it less error prone? So these are the questions that happen in this mode. What's costing the team the most friction, and how can I remove that friction? All right, innovation mode. And this is future forward. This is looking forward and saying, innovation is creativity with a job to do. So the job to do is make our world better, make our product better, make our project better. We should be looking at research. We should be collaborating with others and thinking about next 1, 2, 3, 5 years ahead to say, by the time we're 2 years from now, how do I want to be doing what we're doing? Is there current or new tech that we should be looking at to solve our current state of the world or change the way we're doing things? And this here, I mentioned one of the things was Test Kit Gen. We trialed and it worked, so we brought it in. But this is also having that results summary service and now inserting some machine learning there. So taking the approach that we will try things, see if they work, and then build upon them, build them to be part of our approach. The open source readiness mode, this one for us at the open source project is pretty important. It's about creating community as well. So I do like this quote, and you feel free to read it through, but having that tribe or that community of people working together on things, having lots of eyes on the things we do, that's absolutely important to us. And the using open source tools rather than proprietary in-house. Nobody who ever writes an in-house proprietary tool will write enough documentation, as an example. So when you go to try to fix something and look at the doc to see, or you will end up scouring through the code that was written for it, you'll end up probably causing new people on the team to want to leave because they're not actually learning tools that make them look good to other opportunities. So there's a lot of reasons here why open source readiness mode is important. But let's talk a little bit about how would we measure success in each of these modes. How are we doing well for how we think about our work and how we dismantle our technical debt, how we make our projects better? So in in the maintenance mode, these are just examples of some metrics that we could use. Size of the test defect queue would be something I would look at. Is it growing? Is it shrinking? Number of frameworks. I mentioned that when we started, that one of the war stories was before we open sourced a bunch of test material, we had to wade through over 20 different proprietary test frameworks and try to reduce those. So I'm just going to say, again, another audience participation thing. I haven't created an actual poll for this, but if you were going to say for each one of these metrics, what direction is better? Is execution time of test jobs, should it go up or down? Which would indicate success? Or innovation, number of intermittent defects, is it better to have those go up or down? So you can have some fun playing with which direction do you think each one of these metrics should go in. I think most of them are relatively obvious, but it is worth thinking about from the perspective of your own projects. How many steps does it take me to do a common task? Can that be, should it increase or decrease? So, and I won't go too much into detail of this because I've already talked a lot about it, but I do want to then talk about this briefly about the number of frameworks to manage. So how we looked at that example of we have 20 proprietary frameworks that were in use and a bunch of proprietary things. They're all marked in red. Couldn't get all the way over to the open source approach in one leap, but took iterative approaches. So let's take the first step and reduce from 20 frameworks to 5, which meant rewriting some tests, which meant doing some work to port tests into other frameworks. But it got us out of the maintenance mode of 15 frameworks that didn't have documentation. So this is what I mean by dismantling technical debt. But there's not really any time for war stories. You can ask me later. Quickly, I wanted to go to the success metrics of development transformation. We talked about some of them already, but one of the ones that I find useful, although it's a little bit costly to gather, and we'll have to improve how we gather these metrics, but is the defect escape analysis. So if you're running testing at your project and defects escape out to customers or consumers, let's look at that and let's see what was the type of problem that the customer faced. Was it a crash? Was it a hang? When was it found? Was it found as it went to the customer, or did we find it in a system level test or in a unit test? And when would have been our first chance to find it? And this is where it takes actual thinking and looking. Could we have found this problem in a code review? Could we have found it only in a performance benchmark? Assessing that so we can improve how we work is very, very useful. And I won't go into detail about the TKG example because I think I'm running low on time, but I would love to talk about this later if people have questions. And these are always things that we are constantly improving. So finally, for innovation, I will say one of the examples that I have is looking at using deep learning for test triage and automating the triage. And why? Because test triage is painful. No one likes to do it. It's done in a very haphazard way. Sometimes people have different approaches. So if we could standardize and make that a little bit easier and automate it and lift that off of the shoulders of the team, that's something we'd like to do. So prototyping this is in our innovation mode. And finally, with the open source readiness, lots of things you can look at. How many people contribute, how many people have forked your repo, number of issues that external parties raise, because that means they used your stuff and they actually care enough to report issues. All right, so we've finally arrived at the end. What are my tips for success for you in whatever level of project, however long-lived it is, in terms of dismantling technical debt if you have it? So the notion is you actively reducing it along the way. Don't leave it until it's so accumulated that you're crushed by it and you can't move. Take it on with each iteration, do a little bit as you go, refactor as you need, or you'll suffer death by 1,000 cuts. Make sense of the noise in whatever way you need to. I've described how we do it with categorizing things into different modes of activity, but just organize it. Recognize the egos in the room. So if there are people that are loud and making decisions that are hurting the project and causing more technical debt to happen, you're going to have to call that out. Ignore people who say, no, things aren't impossible. The naysayers, you can't do it, it's too hard. Well, until you actually try some things, that voice might not be correct. And then measure and adjust. The metrics are critical. You have to be measuring along the way and adjust as you go based on what you've measured. Final tip, remember your mission. So keep it clear what your goals are so that you can continue towards them, because all that noise might cause you to change direction. Always have your goal in mind and remember where you're headed. And that's it. Essentially, the short answer is stop the stupid.
Nice. Okay, so let's look a little bit at a couple of polls that run in there. So regarding our audience, who are the people that joined us during this call, 40% said that they're working on projects that span for more than 10 years.
Ooh,
so pretty much like in your station, in your shoes.
Yeah, that's cool.
13% said that less than a year. So fairly, short living project, and the rest is distributed more or less evenly. I also came up with a question that during your talk that you were now, because you were talking about putting kind of like garbage under the carpet, under the rag, saving it for later. So I ask a simple question: do you stick to policy tests are always green? So 3/4 said yes. 1/4 said no, and I was one of those because, frankly speaking, I do have every once in a while we do observe. Oh, we haven't looked at test results for quite a while. Apparently, they turned red a while ago. So I was one of those people that said no, but most people said yes, and somebody suggested that maybe people just run tests with like some sort of a flag that makes them green while they aren't. So that is our audience. And I know that you ran some so you had some additional questions that we did not have time to go into, but I would like to invite each and every one of you who is online to join us on a Zoom chat right after this talk, and we will go there and have more discussion. I hope maybe we can discuss your project, maybe we can dive into details, maybe we can actually share some talks a little bit about war stories that we all face, because each and every developer eventually runs into some sort of technical depth with testing, and you can't really just say, no, it's like somebody else's job. Maybe it's peers should fix it, maybe QA should somehow fix it, I guess by disabling tests or something.
That's true.
But we do have, and the senior you become in your career, the more attention you start paying to testing and all things related to that. So I think it's a very important topic. So I'll really hope that we discuss this in the Zoom channel.
I agree with Juan. Thank you very much for your talk. For now, it's everything clear for me, but I think we still have a lot of questions, and I invite you to discussion zone. Thank you.